Okay, today we'll discuss what is S3 encryption. First of all, thanks for clicking this video. You'll watch this video for the end for sure. So first of all, what is encryption? I know many people know this, but give me 10 seconds, I'll explain. Encryption is just a process of converting some secure information to unreadable form so that only authorized people can read it. This process uses a key to encrypt the data, which means lock the data, and only someone with the correct key can unlock the data, which means decrypt the data. So, encryption keeps your information safe from being read by others. This video is on S3 encryption. I'll take you to my console now. This is a page for creating a bucket. I'll come down a little bit. Here it is, Default Encryption. This is a place where we encrypt our S3 objects and store in the bucket. There are different methods: server-side encryption with S3 managed keys, server-side encryption with KMS, and dual-layer server-side encryption with KMS. And by default, AWS uses this server-side encryption with S3 managed keys. So what is this server-side encryption? There are two different types of encryptions: client-side encryption and server-side encryption. Client-side encryption is, while uploading the object, you encrypt the object and store it in the bucket. And server-side encryption is, you don't need to do anything. AWS itself encrypts your data before storing it in the bucket. And while retrieving the object from the bucket, AWS decrypts and give it to you. Now I want to ask one question to you. We all want encryption while the object was traveling through the internet. But all these methods are server-side encryptions, which means object will be encrypted once it has reached to S3. But why we need encryption when the object has successfully reached to S3? So, when you upload an object to S3, AWS makes sure that it is securely transmitted from local to AWS using HTTPS. This is what we call encryption at transit. Although AWS provides some good security, there is always a possibility of some leakage. And that's why encrypting your object is super important even after the object has reached to S3. So, now let's dive deep into how S3 encrypts the object. Firstly, let's understand what is this server-side encryption. As I already said, after the object has successfully reached to S3, S3 itself encrypts your data before storing it in the bucket. This is also called as encryption at rest. I have already shown you in the console. There are four types of server-side encryptions: server-side encryption with S3 managed keys, server-side encryption with KMS managed keys, server-side encryption with client managed keys, and dual-layer server-side encryption. So firstly, server-side encryption with S3 managed keys. I hope you already know keys are responsible for encrypting your data with some encryption algorithm. If the key is symmetric, then same key is used to decrypt the data. And if the key is asymmetric, different key is used to decrypt the data. So what is this S3 managed keys? Encryption is automatically handled by S3 and no key management is required. Which means you don't need to provide any keys, you don't need to provide any encryption algorithm, you don't need to do anything. Of course, you need to provide object. In all these server-side encryptions, S3 uses AES 256 encryption algorithm. Now, I'll take you back to my console. This is the page where we create a bucket. I'll come down a little bit. Here it is, default encryption. By default, this SSE S3 option will be set. By default, S3 takes care of complete encryption of your object before uploading it to the bucket, and you don't need to do anything. If you select this option, S3 uses its own internally managed keys to encrypt and decrypt your data. And you don't have any control over these keys. They are fully managed by S3. And if you select this S3 managed keys option, S3 by default uses this key to encrypt your object. And you can't see this key in the KMS service. And you also cannot change this key that this SSE S3 was using. And if you observe, this is a bucket level setting. And while uploading object, you can change this encryption. For suppose, in this bucket level default settings, you have selected this KMS managed keys option. And while uploading the object, how do you specify S3 that you want to use this S3 managed keys? I am not talking about the console, I am talking about CLI. While uploading the object using S3 API command, if you put this server-side encryption is AES 256, then S3 uses this S3 managed keys to encrypt your object. And that's fine. Now let's learn server-side encryption using KMS managed keys. But before that, I want to tell you a bit about KMS service. KMS is a key management service. Is a fully managed service that helps you to create, manage, control these keys which are used to secure your data. Services like S3, EBS, RDS and Lambda uses this KMS by default for encryption at rest. Now let's learn a different types of KMS keys. First is AWS managed keys. AWS manages the key. You cannot enable, disable or delete or able to control the key. AWS by default creates one key per region per service. And this one key will be used for all the resources of a particular service. For example, all the S3 buckets will use only one key. You cannot view this AWS managed keys in the console until you use it. And usage charges will be there for this AWS managed keys and no monthly charges. And next is customer managed keys. You manage the keys. You can enable, disable, delete, whatever you want. You can create multiple keys and one key can be used for all the resources for a particular service. Monthly charges will be there as well as usage charges will also be there. And next is AWS owned keys. These keys are created and used by AWS for internal encryption across different AWS services. Users can't see these keys. For example, our SSE S3 uses this AWS owned keys. Now it's time to understand the server-side encryption using KMS. When we select this option, S3 uses a KMS key, whether it can be a AWS managed key or a customer managed key for encryption. Now I'll take you to my console. When I select this second option, server-side encryption with KMS, I'll select the first option, choose from AWS KMS keys. When I select this drop down, these two keys are customer managed keys. That means I have created these two keys in this AP South 1 region. And this last key was already there by default. When I select the last one, AWS S3, if I click create bucket, when I upload an object, then only I can see AWS S3 in AWS managed keys in KMS service. How to do it using CLI? While uploading object using S3 API, if you put --server-side encryption AWS :KMS, then S3 uses that AWS managed key in KMS to encrypt your data. After running this command, you can see that AWS managed key is present in KMS service. Until a resource uses the managed keys, they are not displayed in KMS. For suppose instead of using that managed keys on which we don't have any control, if we want to use our own key created in KMS, then how to do it? After writing server-side encryption is AWS KMS, we have to specify the key ID by SSE-KMS ID. If you run this command, S3 encrypts the object using the key which has this ID in the KMS service. Now let's have some closer look into how this encryption all happens. This KMS service uses envelope encryption method to encrypt your data. When you or AWS creates a key in the KMS and use this key, it generates two keys. One is plain data key and other is encrypted data key. This plain data key is responsible for encrypting the S3 object, and this encrypted data key is stored along with the encrypted object. And during decryption, this key gets utilized. This is how an encryption works in KMS. Once encryption is done, plain data key gets deleted and the KMS key is really safe, and this key never leaves the KMS service. When we want to view the encrypted data, as S3 contains this encrypted data key, S3 makes a decrypt API call to KMS, and then KMS sends a plain data key as a response, and this plain data key is used to decrypt the data. This is how encryption and decryption works in KMS. Note that the data key which is used to encrypt the data, the same data key is used to decrypt the data, which confirms this is a symmetric key encryption. Do you remember at the beginning of the video, I said in all these server-side encryptions, S3 uses AES-256, and that AES-256 is a symmetric key encryption algorithm, which means while uploading the object, if you mention a symmetric key ID here, this won't work. I said before that, for many resources, I can use the same KMS key. That doesn't mean that all the resources are encrypted by the same data key. One KMS key can generate different data keys to encrypt different resources. Now let's understand this server-side encryption with client-provided keys. You as a user need to provide the key for encryption and manage the encryption key. S3 does not store a key at all, and AWS does not have an access to do it. While uploading the data, you must provide the key for encryption. While downloading the data, you must provide the same key for decryption. And encryption algorithm remains the same. You cannot change this encryption algorithm. How to do this type in action? First of all, I'll generate an encryption key using OpenSSL command in Linux. This OpenSSL command generates a random 32-byte key, which means 256-bit key, and stores it in the mykey.txt file, which is base 64 encoded. And while uploading the object to the bucket, I'll pass this key. You might ask me that I said you cannot change the encryption algorithm used, but what is this SSE customer algorithm? This field accepts only AES-256. And while downloading the object, you need to pass the same key. There is a concept called bucket versioning. Using that, different versions of the object can be encrypted with different keys. Now let's understand what is this dual layer server-side encryption with KMS. Here, there are two separate layers of encryption applied to the data. The first layer, the data is encrypted using the data key, and this data key is generated by either S3 managed key or KMS. And in the second layer, the data key from the first layer is further encrypted using the separate KMS key. How to do this? In the server-side encryption field, if you write AWS:/KMS:/DSSE, which means dual layer server-side encryption, then using this encryption method, S3 encrypts the object. If you don't mention the key ID, S3 uses S3 managed keys. If you want to mention the key ID, you can. So in all these server-side encryption methods, AWS takes care of this encryption and decryption process. Now let's have a look at client-side encryption. In this, you don't send any keys to S3 to encrypt the object. Instead, you will encrypt the object and send to S3. And again, S3 don't use the default SSE-S3 option to encrypt. While downloading, S3 sends you the encrypted file. You need to decrypt with the key you have. Here you can use whatever the encryption algorithm you want. Now I'll take you to my console. There is a small option called bucket key, which is enabled by default. This small option has a big impact in the KMS builds. When we try to upload and download the objects to bucket using KMS, S3 makes a encrypt and decrypt calls to KMS. And if there are many objects and many retrieve object calls are being made, then this could ramp up the bill. Using this bucket key, the KMS bill get reduced by 99%. If you enable this bucket key option and use KMS keys for encryption, that KMS key generates a bucket key and encrypted bucket key instead of data keys. This bucket key generates a data key and encrypted data key. This data key, as usual, is used to encrypt the data. S3 stores this encrypted data key and encrypted bucket key, and S3 deletes these data keys. And during decryption, as S3 contains encrypted data key, this must be decrypted with a bucket key. S3 also contains this encrypted bucket key, right? Now S3 requests KMS for the bucket key for the corresponding encrypted bucket key. Now KMS gives a bucket key as a response. Now this bucket key is used to decrypt the data key, and the data key decrypts the data and returns it to the user. This whole process is useful only when frequent calls are being made to S3 object. If not, this doesn't make sense. S3 temporarily stores a bucket key. If in this time, get object calls are made to S3, S3 need not to request the KMS service for the bucket key, as it already has the bucket key. If frequent calls to the object are not being made, then bucket key will go after some time. Then S3 has to repeat the whole process again. Then enabling bucket key has no use, right? When new object was uploaded to S3, this bucket key generates a new data key and encrypts the object and stores the encrypted data key. And this process repeats. Okay, that's it for this video. I hope you liked it. In the next video, we'll look at what is CORS in S3 and subscribe for more.